The world's largest and most powerful space telescope has revealed unprecedented views. Scientists are optimistic that they have identified a planet with the most definite signs of life. The universe has always been a mystery, a vast expanse of stars and galaxies waiting to be explored. Humanity's curiosity about what lies beyond our world has led us to develop ever more advanced technologies to peer into the distant reaches of space. Among the most significant of these innovations is the James Webb Space Telescope, JWST, a marvel of modern engineering. The JWST has exceeded expectations in its ability to capture incredibly detailed images and data from the farthest corners of the universe. Recently, it has made a discovery that has taken the scientific community by storm. Signs of artificial light just 4 light-years away from Earth. For decades, astronomers and astrophysicists have speculated about the existence of extraterrestrial civilizations. While we have found planets in the so-called habitable zone, regions around stars where conditions might be suitable for life, we've never detected concrete signs of advanced civilizations. However, with recent findings from the James Webb Telescope, that may have changed. Just 4 light-years from Earth, in the Alpha Centauri system, the JWST has observed something extraordinary: the unmistakable glow of artificial lights. This revelation is groundbreaking, not only because of the proximity of the system, but also due to the potential implications for our understanding of life in the universe. Alpha Centauri has long been a target of interest for scientists searching for life beyond our solar system. It's the closest star system to Earth, consisting of 3 stars: Alpha Centauri A, Alpha Centauri B, and Proxima Centauri, the latter of which is a red dwarf. A round Proxima Centauri orbits Proxima b, a planet located within the habitable zone of its star. Since its discovery in 2016, Proxima b has been the subject of intense scrutiny. It's an Earth-sized planet with conditions that might allow liquid water to exist on its surface. The excitement around Proxima b has only intensified with the discovery of what appears to be artificial light emanating from its surface or near the planet. The JWST, with its unprecedented sensitivity to infrared and visible light, picked up a pattern that seemed out of place in the natural nightscape of Proxima b. Unlike the soft glow of starlight or the faint emissions from planetary atmospheres, the light detected by the telescope exhibited characteristics that closely resemble urban lighting as we know it on Earth. The discovery raises tantalizing questions. Could this be evidence of a technologically advanced civilization? And if so, how long have they been living just a stone's throw away from us in cosmic terms? One of the most intriguing aspects of the discovery is the regularity of the light emissions. Natural light sources, such as stars or even bioluminescent organisms, typically follow patterns dictated by physical laws or biological rhythms. The light observed near Proxima b, however, shows regular intervals of brightening and dimming, akin to the structured illumination patterns seen in cities on Earth. This has led researchers to hypothesize that we might be witnessing the glow of an urban landscape, perhaps entire cities stretching across the surface of the planet. The implications of such a discovery are profound. First and foremost, the presence of artificial light suggests the existence of a civilization capable of creating and sustaining advanced technology. This civilization would have likely overcome many of the same challenges humanity has faced, from harnessing energy to manipulating materials to building large-scale infrastructures. If the lights we are seeing are indeed the result of a civilization, it could mean that they have achieved technological milestones similar to or even surpassing our own. Moreover, the proximity of Proxima b makes it an even more tantalizing prospect. At just over 4 light-years away, it's within the range of future interstellar exploration. While current human spacecraft would take thousands of years to reach Proxima b, advances in propulsion technology could drastically reduce that time. Concepts such as the Breakthrough Starshot initiative, which aims to send tiny spacecraft to Alpha Centauri using powerful lasers, may one day allow us to directly explore the system and perhaps even communicate with whatever civilization may be there. The discovery of artificial lights also compels us to rethink our place in the universe. For centuries, humanity has looked to the stars and wondered whether we are alone. While the search for extraterrestrial life has often focused on microbial organisms or basic forms of life. The potential discovery of an intelligent species so close to us changes the game entirely. If we are not the only technologically advanced civilization in our cosmic neighborhood, it raises questions about how common life might be throughout the galaxy. It also brings to the forefront the need for protocols on how to approach and communicate with alien civilizations, should we ever make contact. There's also the matter of what kind of civilization we might be dealing with. Are they peaceful, cooperative, and curious, like we aspire to be? Or could they be more advanced in ways that pose potential risk to us? The lights themselves don't tell us much about the culture, politics, or motivations of the beings that might have built them. But they do provide a hint that we may soon be able to study these questions more directly. It's possible that the civilization on Proxima b has already detected us in some way. After all, our own artificial lights and radio signals have been beaming out into space for over a century. Have they been observing us much as we are now observing them? For scientists, the discovery presents a wealth of new data to analyze. The JWST observations provide only the initial clues, and further study will be necessary to confirm the true nature of the lights. Could there be other explanations for the phenomenon? While natural processes could be behind the regular light emissions, the structured pattern and timing make it less likely. For example, a natural planetary phenomenon like volcanic activity might produce irregular light, but not with the consistency that has been observed. As the scientific community dives deeper into the data, the excitement continues to build. Speculation abounds about the nature of the civilization that might exist on Proxima b. Some theorize that they could be in a post-industrial phase, having solved issues related to energy production and environmental sustainability. Given the harsh conditions of a planet orbiting a red dwarf star, Proxima b receives much higher levels of radiation than Earth, which would pose significant challenges to life as we know it. Any civilization living there would have had to develop advanced technologies to protect themselves, perhaps through artificial shields or underground cities. The lights we are seeing might be the product of a society that has mastered the use of sustainable energy, creating an efficient, low-impact urban environment that minimizes waste and environmental damage. Alternatively, the lights could be the result of a civilization in transition, one that is beginning to industrialize much like humanity during the 19th and 20th centuries. If that's the case, we may be witnessing a society on the brink of significant technological and social development. This could provide valuable insight into how civilizations evolve and the challenges they face as they grow. It might even offer clues about our own future as we strive to create a sustainable world amid the pressures of technological advancement and environmental degradation. The discovery also opens up new questions about the nature of interstellar civilizations. If there is indeed intelligent life on Proxima b, why have they not made contact with us? It could be that they are simply unaware of our existence, or perhaps they've detected us and chosen not to interfere. Alternatively, they may be communicating using methods or technologies that we have yet to understand. Radio waves, for example, may be an outdated form of communication for a civilization more advanced than our own. They could be using quantum entanglement or some other form of communication that we have not yet mastered. This possibility highlights the need for us to continue developing our own technologies and methods for detecting and interpreting signals from across the cosmos. Looking ahead, the discovery of artificial lights around Proxima b has reignited discussions about the future of space exploration. While robotic probes and telescopes like the JWST have made incredible strides in recent decades, the prospect of finding intelligent life just a few light years away underscores the need for human exploration beyond our solar system. The technology for interstellar travel is still in its infancy, but the motivation to push the boundaries of what is possible has never been stronger. Governments, private companies, and international organizations are increasingly investing in space exploration, and the discovery of potential extraterrestrial life will only accelerate these efforts. The existence of an advanced civilization so close to Earth also raises ethical questions about our role in the universe. If we do eventually make contact with the beings on Proxima b, how should we approach that interaction? Humanity's history of exploration on Earth is fraught with examples of exploitation and conflict. and we must take care to avoid repeating those mistakes on a cosmic scale. Any future encounter with an alien civilization will require careful consideration of the social, political, and ethical ramifications. How do we ensure that we approach such a momentous occasion with the respect and humility it deserves? In addition, the discovery might inspire a new generation of scientists, engineers, and explorers. The idea that intelligent life exists within our reach could capture the imaginations of millions and drive humanity to expand its efforts in space exploration, technology development, and even philosophical reflection. It forces us to reconsider the limits of our understanding and the possibilities that await us in the vastness of space. The discovery of artificial light near Proxima b has set the stage for one of the most significant moments in human history. As the scientific community begins to digest the implications, there is a growing sense that this event could be a turning point in our understanding of the cosmos and humanity's place within it. While the initial discovery by the James Webb Space Telescope, JWST, has already stirred imaginations and provoked questions, the path ahead is filled with complexities that extend far beyond the simple detection of light. As researchers delve deeper into the data, they are beginning to realize the immense challenges and opportunities that lie before us. These challenges range from understanding the nature of the signals to grappling with the cultural and ethical implications of potentially interacting with an extraterrestrial civilization. One of the first tasks for scientists is to determine the true origin of the lights on Proxima b. While the irregularity of the signal suggests artificial sources, caution must be exercised before jumping to conclusions. Astrophysical processes are notoriously complex, and some researchers believe it's still possible that an unknown natural phenomenon could be at play. To determine this, astronomers will need to conduct further observations, collecting data from a range of wavelengths beyond infrared and visible light. The JWST observations were conducted in infrared due to its design, but other telescopes, particularly those equipped to detect radio waves or X-rays, may be needed to paint a more complete picture. It's conceivable that what appears to be artificial light could be explained by a naturally occurring process that we have yet to fully understand. But this explanation seems increasingly unlikely given the consistency and the patterns of the light. If these lights are indeed artificial, the next question becomes whether they are produced by intelligent beings or some form of automated system. In the context of human civilization, urban lighting is a product of advanced societies. However, it's important to remember that the lights we see on Proxima b might not follow the same developmental trajectory as those on Earth. While it's exciting to imagine a thriving civilization not far from us, it's also possible that these lights are the remnants of a once flourishing society now in decline. Or they could even be the product of non-biological activity, perhaps autonomous machines carrying out tasks on an otherwise desolate planet. This brings up the fascinating notion that extraterrestrial life, if it exists on Proxima b, may not be biological in the way we understand it. Advances in artificial intelligence and robotics have led some scientists to speculate that an intelligent civilization might choose, or have been forced, to transfer its consciousness into machines. This concept has been explored in science fiction for decades, but it may be closer to reality than we think. If the lights on Proxima b are indeed artificial, they could be maintained by non-living entities that nonetheless possess intelligence and purpose. The ramifications of such a discovery would be enormous, as it would challenge our understanding of what it means to be alive. If Proxima b does host an intelligent species, biological or otherwise, we will need to develop methods of communication. Currently, the most plausible means of initiating contact would involve sending signals across the light years that separate us. Given the distance between Earth and Proxima b, any messages we send will take over 4 years to reach the planet, and any response would take another 4 years to return. This time lag makes real-time communication impossible, necessitating patience and careful planning. A key question that scientists are grappling with is how to craft a message that is both understandable and non-threatening. It's important to remember that any extraterrestrial civilization will not share our cultural or linguistic history, so we will need to find a universal method of communication. Mathematics is often cited as a potential universal language. as it is based on fundamental principles that are likely to be understood by any technologically advanced civilization. However, even math has its limitations, especially when it comes to conveying more abstract concepts such as intention or emotion. Once contact is established, assuming the civilization on Proxima b is interested in communicating, we will face the challenge of building a relationship across such vast distances. Given the potential for misunderstanding, we must be cautious and respectful in our approach. This discovery represents a historic moment in human exploration and a profound opportunity to learn about our universe and potentially connect with an entirely new form of life. Any attempt at communication must be approached with caution. For one, we have no way of knowing how the inhabitants of Proxima b will perceive us. If they are more technologically advanced than we are, they may view us as primitive or insignificant. Conversely, if they are less advanced, they might see us as a potential threat. Either way, the initial interactions between our two civilizations could set the tone for centuries to come. An interesting possibility is that the civilization on Proxima b, if it exists, has already detected Earth's presence. For over a century, humanity has been broadcasting signals into space. Everything from radio transmissions to television broadcasts to radar signals used in aviation and communications. These signals have been traveling through space at the speed of light, expanding outward in a bubble that now extends roughly 100 light-years from Earth. Proxima b lies within this bubble, meaning that any advanced civilization there could have already detected our presence. If this is the case, it raises the question of why they have not contacted us. It's possible that they are deliberately avoiding communication, either because they do not wish to interfere with our development or because they see us as too primitive to be worth engaging with. The detection of artificial lights on Proxima b also forces us to reconsider our strategies for space exploration. For decades, space agencies around the world have focused their efforts on exploring the solar system, with missions aimed at Mars, the moons of Jupiter and Saturn, and even asteroids and comets. However, the discovery of a potentially habitable planet just 4 light-years away shifts the focus to interstellar travel. While our current technology is not capable of sending humans or even robotic probes to Proxima b in a reasonable time frame, the discovery could spur new investment in developing the necessary technologies. Projects like Breakthrough Starshot, which aim to send small laser-propelled spacecraft to nearby star systems, may become more viable in the wake of this discovery. The promise of discovering an alien civilization just a few light-years away could provide the political and financial motivation needed to accelerate progress in this area. In addition to propulsion technologies, there will be a need to develop new methods of data transmission. Even if we succeed in sending a probe to Proxima b, the challenge of sending data back to Earth will be immense. Light takes over 4 years to travel between the two systems, and any data transmitted by the probe would face the same delay. This means that we would need to design probes capable of operating autonomously for long periods of time, analyzing data on site, and perhaps even making decisions about what information to send back. The implications of this are profound. Not only would we need to develop highly advanced artificial intelligence, but we would also need to ensure that the probe could withstand the harsh conditions of interstellar space for decades, if not centuries. Beyond the technological challenges, there are also ethical considerations to grapple with. If there is indeed a civilization on Proxima b, how should we approach the possibility of contact? History has shown us that first contact between civilizations on Earth has often been disastrous, leading to exploitation, conflict, and even the destruction of entire cultures. We must learn from these mistakes and approach any extraterrestrial civilization with a sense of humility and respect. It's also possible that the inhabitants of Proxima b, if they exist, may have their own ethical frameworks and may not wish to engage with us. In this case, it would be crucial for us to respect their autonomy and avoid imposing our own values or expectations on them. One of the more philosophical questions raised by the discovery of artificial lights on Proxima b is how it will affect our understanding of life's place in the universe. For centuries, humanity has considered itself unique, the only intelligent life in the cosmos. The discovery of another civilization so close to us would force a re-evaluation of this belief. If life has arisen independently on Proxima b, it suggests that life may be far more common in the universe than we previously thought. This raises profound questions about the nature of life and intelligence. Are there universal principles that guide the development of life, or is each civilization shaped by the unique conditions of its home planet? If life is common, it also means that the universe may be filled with countless other civilizations, each with its own history, culture, and technology. The implications of this are staggering. It would mean that humanity is just one small part of a much larger cosmic community. The discovery of artificial lights on Proxima b may also have a psychological impact on humanity. For millennia, we have looked to the stars and wondered whether we are alone. The realization that we are not could change the way we view ourselves and our place in the cosmos. Some people may feel a sense of wonder and excitement at the prospect of discovering another intelligent civilization, while others may feel threatened or fearful. How we as a species respond to this discovery will depend on our ability to adapt to the idea that we are not the center of the universe. This shift in perspective could lead to a new era of cooperation and exploration as humanity unites in the common goal of understanding our cosmic neighbors. Another possibility is that the lights could be powered by an advanced form of energy that we have not yet discovered. Some theorists have speculated about civilizations harnessing the power of their own stars through mechanisms such as Dyson spheres, vast structures built around stars to capture energy directly from them. While Proxima b orbits a relatively dim red dwarf star, the concept of advanced energy harvesting techniques cannot be ruled out. If the civilization on Proxima b has developed technologies that allow them to efficiently capture and utilize energy from their star, it would provide us with invaluable insights into energy sustainability and the future of power generation. Additionally, the existence of artificial lights may give us clues about the surface conditions of Proxima b. On Earth, artificial lights are a nighttime phenomenon employed to compensate for the lack of sunlight when the planet rotates away from the sun. Proxima b, however, may have different dynamics, including a phenomenon known as tidal locking. Tidal locking occurs when a planet's rotation period matches its orbital period, meaning one side of the planet always faces its star, while the other side is perpetually in darkness. If Proxima b is tidally locked, the lights could be concentrated on the dark side, suggesting that its inhabitants have adapted to living in constant darkness. This would present an extraordinary example of adaptability in extraterrestrial life, and could point to a wide range of biological or technological solutions developed by the civilization to thrive in such an environment. Further, the geography of the lights might indicate the presence of large urban centers or, conversely, widely distributed settlements. The patterns and intensity of these lights could tell us whether we are dealing with a densely populated, highly urbanized society or a more decentralized civilization with smaller pockets of habitation. If the light emissions are concentrated in a few regions, it could suggest large metropolitan hubs similar to cities on Earth. But if they are more evenly spread, it might indicate a civilization that favors smaller, more rural communities. Each scenario has significant implications for how this society may be structured, both politically and socially. The existence of lights could also provide insight into the technological age of the civilization. If the light signatures suggest an energy-efficient system, perhaps one that minimizes waste and pollution, it may indicate that this civilization has gone through the same developmental stages that we have on Earth, such as industrialization, and has progressed to more sustainable technologies. In contrast, inefficient or excessively bright lighting might suggest a society still in its early stages of technological development, where energy conservation is not yet a priority. Alternatively, if the lights are dim and faint, it could suggest a post-industrial civilization that has moved away from large-scale energy-intensive technologies, or perhaps one in decline, with remnants of artificial light fading over time. In considering the nature of the possible inhabitants of Proxima b, one of the most important aspects to contemplate is their biology, or in the case of non-biological entities, their synthetic structures. Proxima b receives significantly higher levels of radiation than Earth due to the intense flares of its red dwarf star. This hostile environment would necessitate significant adaptations for life to survive. It's possible that any life forms on Proxima b may have evolved biological defenses against radiation, such as protective skin or even exoskeletons designed to block harmful particles. Alternatively, the civilization may live underground or within domed cities designed to shield them from the harsh surface conditions, which could explain the presence of artificial lights that illuminate these protected environments. If the inhabitants of Proxima b are non-biological, such as artificial intelligences or robotic entities, this raises questions about the trajectory of their development. Did they once exist as biological beings who transferred their consciousnesses into machines to escape the environmental challenges of their planet? Or were they created by a biological civilization as autonomous agents, tasked with continuing their legacy after the species' demise? The prospect of encountering a non-biological civilization brings up profound philosophical questions about the nature of intelligence and consciousness. Are these machines self-aware? Do they have a culture, art, history, or spirituality akin to human societies? Or are they purely functional entities that exist to serve a specific purpose? The discovery of artificial lights could also lead to a better understanding of the environmental state of Proxima b. On Earth, light pollution is a major issue, especially in industrialized regions. By examining the levels of light pollution on Proxima b, scientists may be able to infer the degree of environmental degradation, if any, caused by the civilization there. If the lights are scattered across the planet without significant regard for natural ecosystems, it may suggest that the civilization is struggling with the same environmental issues that we are facing on Earth, such as overconsumption of resources, habitat destruction, and pollution. On the other hand, if the light emissions appear to be concentrated in specific areas, leaving vast regions of the planet dark and untouched, it could indicate a society that has developed in harmony with its environment, preserving natural ecosystems while still maintaining an advanced level of technology. The socio-political structure of the potential civilization on Proxima b is another aspect ripe for speculation. The distribution and patterns of the lights may reveal clues about the governing systems in place. A tightly concentrated cluster of lights might suggest a centralized government, possibly a single authority or a cooperative entity that controls the majority of the planet's population. If the lights are more dispersed, it might indicate a decentralized system, perhaps one based on smaller independent communities or regions, each with its own governance. Understanding how a civilization organizes itself politically and socially could offer us invaluable lessons for our own future development, particularly as humanity begins to expand beyond Earth and into space colonization. The sheer proximity of Proxima b also prompts us to reconsider the timeline for potential interstellar exploration. Currently, our best ideas for reaching another star system involve spacecraft like the ones proposed in the Breakthrough Starshot initiative, which would involve sending small, lightweight probes at a fraction of the speed of light using powerful lasers. Though it would still take decades to reach Proxima b using this method, the discovery of artificial lights there could act as a catalyst for accelerating development in propulsion technology. Breakthroughs in energy production, materials science, and propulsion mechanics may allow us to reduce the travel time to Proxima b to just a few decades or even less. While the challenges are immense, the motivation to explore a nearby system that may host intelligent life could provide the impetus needed to make significant advancements in space travel. The prospect of establishing contact with an alien civilization, however, presents an entirely different set of challenges. Humanity would have to develop an entirely new field of diplomacy, interstellar diplomacy, alongside a rigorous framework for ethical interactions with extraterrestrial beings. There is no precedent for such an endeavor, and the stakes are high. Any contact with an alien civilization could have profound implications for both societies. Establishing peaceful relations would be paramount, but this raises questions about how to communicate intentions across such vast distances. Would it be possible to convey messages of peace and cooperation without causing misunderstandings? The margin for error is slim, and any misstep could result in unintended consequences. One of the first steps in preparing for potential contact with extraterrestrial civilizations is developing a universal protocol for communication. Scientists are currently working on ways to encode messages in mathematics or other universal concepts that are likely to be understood by intelligent beings. But beyond the technicalities of communication, there are the philosophical questions. What do we say to a species that may have a completely different understanding of life, death, ethics, and existence? Do we start by explaining who we are, where we come from, and what our goals are? Or do we begin by asking them questions, seeking to understand their civilization before offering information about our own? There are also significant cultural considerations to take into account. Each human society has its own values, beliefs, and norms, and it's likely that any extraterrestrial civilization would be similarly diverse. However, these values may differ radically from our own. For example, an advanced alien civilization may not prioritize individual freedoms or democratic governance in the way that many human societies do. They could have a completely different set of ethical principles based on their unique evolutionary or technological history. This brings up the question of how we engage with a culture that might be entirely alien to us. Should we attempt to share our own values, or should we focus on learning from them, reserving judgment about their way of life? If you like this video, please give it a like and subscribe to our channel. Also, leave your comments below and tell us what you think the James Webb Telescope discovered near Earth. We want to hear from you. Thank you for watching.